Saturn's rings are one of the most recognizable structures in the solar system. Bright, expansive, and seemingly timeless. For centuries, it was assumed they formed billions of years ago alongside the planet itself, but recent discoveries have turned that idea on its head. Cassini data revealed Saturn's rings are young, no more than a few 100 million years old. It's astonishing to think that they formed when dinosaurs ruled the Earth. But that was just the start. It left scientists wondering not only how the rings formed, but what else in the Saturnian system might be part of the same story. In February of 2026, a new study gave us an answer. A cataclysmic chain of events with far-reaching consequences that played out in the cosmic equivalent of a blink of the eye. And it was driven by none other than Saturn's largest moon, Titan. I'm Alex McColgan, and you're watching Astrum. Join me as we get to the bottom of Saturn's biggest mystery. We'll explore the gravitational dance between the gas giant, its rings, and its many moons. And we'll reveal how their deeply interconnected relationship led to a trail of destruction. When Galileo Galilei turned his telescope to Saturn in 1610, the first person in history to do so, he was baffled. It appeared as if the planet was sandwiched between two very large moons. But when he looked again 2 years later, they were gone, only to reappear as what he described as arms or handles another 2 years later. Through his groundbreaking, albeit crude, early telescopes, what Galileo was actually witnessing was our shifting perspective of Saturn's rings. Because Saturn is tilted at 27 degrees, its rings angle towards Earth and then away again as the gas giant orbits the Sun. When it appeared to Galileo that they'd disappeared, he was viewing them straight on. It took nearly 50 years for telescope optics to improve enough for astronomers to correctly identify the strange structure. And in 1659, Christian Huygens deduced that the arms Galileo had described were in fact a ring. He was also the first to identify Titan, Saturn's largest moon. As telescope technology continued to improve, so did our view of the surprisingly complex Saturnian system. The French-Italian astronomer Jean-Dominique Cassini soon discovered 4 other major moons: Iapetus, Rhea, Tethys, and Dione. And in 1675, he was the first to see a gap in Saturn's rings, now known as the Cassini division. The next big breakthroughs in our understanding of the rings came in the 19th century, including the work of James Edward Keeler, who demonstrated that they could not be solid, uniform sheets, but were instead composed of countless small particles, each orbiting Saturn independently. But it wasn't until the late 1970s that the full intricacy and beauty of the system became clear. Pioneer 11 and the Voyager probes changed our understanding dramatically, as with each mission came greater resolution. By the time Voyager 2 flew past in August of 1981, it showed for the first time that the A, B, and C rings were actually comprised of millions of smaller ringlets. And then came Cassini. Orbiting Saturn for more than a decade, it passed through the gaps between the rings, skimmed their edges, and, for its closing act, plunged between the planet and the innermost D ring. The data it sent back has revolutionized what we know of the Saturn system, not only painting an extraordinarily detailed picture, but telling a story that no one expected. Saturn's rings are astonishingly thin, between 10 meters and 1 kilometer thick, yet they extend up to 282,000 kilometers from the planet. Named alphabetically in the order they were discovered, they are called the D ring, C ring, B ring, A ring, F ring, G ring, and E ring. And there is a final and very faint Phoebe ring, much further away in the orbit of the moon with the same name. The particles are kept in their orbits by Sheppard moons. Pan, Daphnis, and Prometheus sit within the ring system itself, while Pandora, Janus, and Epimetheus sit just beyond the F ring. Mimas, discovered by Herschel in 1789, orbits further out, but exerts an oversized level of control on the rings. I've made another video on Mimas that you can watch here if you want to find out more. By the end of the Cassini mission, Saturn's known moon count stood at 62. But the discoveries didn't stop there. Advancements in ground-based telescopes and recent surveys put the latest moon count at a staggering 292, and it's still rising, more than any other planet in our solar system. And as a collection, they are extraordinarily diverse. There are large regular moons which orbit close to Saturn in the same general plane, and a whole host of irregular moons that are much smaller, more distant, and on eccentric orbits. There are even tiny ring moons shaped like ravioli, as dust particles from the rings accumulate around their equators. You may wish you had a collection as diverse and interesting as Saturn's. This is a planet that knows how to showcase its marvels, and you need to bring your A game to be on its level when it comes to home decorating. But that's more possible than ever thanks to the sponsor of today's video, Displate. Displate is the home of a collection of high-quality metal posters even more diverse than Saturn's moons. There are 2 million designs to choose from, iconic brands like Marvel, Lord of the Rings, Dragon Ball and Star Wars, beautiful vistas of auroras and galaxies from their NASA collection, and more. And if somehow that's not enough, you can create your own custom displate using your own uploaded image. I have several displays up on my wall at home. I like the Mustang and the Van Gogh, and the James Webb and NASA ones always remind me of the beauty of the universe around us. Installing or swiping out was easy. It was literally just putting a magnet on your wall with a sticker to hold the metal poster in place. And of course, Astrum has our own collection there, with its very own beautiful sweeping showcase of the Saturnian system, among many others. Buying our designs for yourself or as a perfect gift can be a great way to support the channel. And right now, Displate is running a promotion where there's 22% off if you buy 1 poster, 27% off if you buy 2, and 33% off if you buy 3. Just scan my QR code or click the link in the description below, then use my code ASTRUM at checkout. Go give it a look. Now back to Saturn's collection. The Saturnian system is far stranger than Galileo could have ever imagined when he thought the planet had handles. Cassini's measurements of the rings also revealed what they're made of, and that is 99.8% water ice, with particle sizes that range from smaller than a grain of sand to as big as a mountain. The reflectivity of the ice crystals is what makes the rings appear so bright, even from Earth using Galilean telescopes. Cassini data also allowed scientists to calculate the mass of the rings, around 16 quadrillion tons. This sounds huge, but it's actually less than 0.02% the mass of our own moon. Combining these two observations led to a scientific bombshell of a question, and in turn, a discovery. Over time, micrometeorite impacts and space dust pollute water ice and darken it. So why were Saturn's rings so bright? The mass of the rings helped scientists determine how much dust would be needed to contaminate them, and thus work out how long it would take to darken them. The low ring mass implies that they likely formed only 10 to 100 million years ago. That's the blink of an eye in the 4.6 billion year history of the solar system, and vastly different from what was thought at the time. Until this point, some scientists had believed the rings were always there, that they had formed alongside the planet. Instead, dinosaurs had already roamed the Earth for about 150 million years before Saturn's rings were thought to have formed. The question then becomes, how did the rings get there? This conundrum was first tackled by Edouard Roche in 1849, who explored why rings are only found around the giant planets. He suggested that the tidal forces between moons and their planets, the same ones that cause ocean tides here on Earth, could become so strong that they could overcome the gravity that holds a moon together. If a moon came too close to a planet, these forces would rip it apart, its remnants spreading along its original orbit to form a ring. He calculated the minimum safe distance for a moon's orbit as about 2.5 times the planet's radius from its center. This is known as the Roche Limit. For Saturn, this is 87,000 kilometers, and aligns with the location of the F ring. As the Cassini data built, it became clear that something catastrophic had happened in the Saturnian system long after it was formed. In 2022, a team at MIT hypothesized that the rings formed after the destruction of an additional moon that orbited between Iapetus and Titan, which they named Chrysalis. They proposed that Chrysalis's orbit was disrupted by Titan's gravity, causing it to be pushed too close to Saturn. As it approached, it was destroyed, and the debris spread to form the rings we see today. However, when the scenario was modeled by researchers at the SETI Institute, who published their results in February of 2026, it was much more likely that Chrysalis would have collided with Titan rather than being pushed towards Saturn. In this case, most of the debris would have been captured by Titan's gravity or lost from the system entirely. It wouldn't have been able to form rings. The team, led by astrophysicist Matija Chuk, also noticed that in the Chrysalis models, Hyperion, a small, misshapen and constantly tumbling moon, was more often than not completely lost during the upheaval process. But we can see Hyperion is very much still there today, and what's more, we know that its orbit is locked with Titan. The eureka moment for Chuk was to recognize that this Hyperion-Titan relationship is relatively young and dates to the same period that Chrysalis would have disappeared. Hyperion wasn't a simple survivor of a shifting system, but a result of it. Chuk and his collaborators decided to take a wider view of the Saturnian system to explore how the rings might have formed. This included Saturn's axial tilt, I mentioned earlier that this is about 27 degrees, as well as observations of its many moons. By approaching the problem as an interconnected system rather than looking at each phenomenon in turn, they were able to simulate how the events played out over hundreds of millions of years. They concluded that Titan likely did collide with an additional moon, one that was 4 times more massive than the proposed Chrysalis. They termed it Proto-Hyperion, since Hyperion had come out of the event. Titan at this time was also different, smaller, and in a more circular orbit than we observe today. In their simulations, a Proto-Hyperion, Proto-Titan collision occurred in 42 simulations out of 60, and in the runs without a collision, either Proto-Hyperion or Iapetus were ejected from the system altogether. They proposed that the collision happened 400 million years ago, and it set in motion a chain of events that can account for many of our present-day observations. So, what actually happened? The team traced the line of evidence back to a time when Saturn slipped out of spin-orbit resonance with the other planets. Resonance is when 2 orbiting bodies fall into a repeated rhythm. They keep meeting up in the same configuration, and over time, tiny gravitational tugs from each interaction add up, amplifying their influence over one another beyond what a single encounter would allow. In the case of Saturn, that small change was enough to destabilize Proto-Hyperion and put it in a 2-1 resonance with Proto-Titan, the strongest resonance there is. For every orbit Proto-Titan made of Saturn, Proto-Hyperion made 2. This caused Proto-Hyperion to start moving inwards quickly, not only setting it on a collision course with Proto-Titan, but yanking the orbit of Iapetus on its way and pushing Iapetus into a highly tilted orbit. Eventually, the paths of the 2 proto-moons crossed, and all hell broke loose. The Titan we observe today is larger than Mercury and is Saturn's biggest moon. As the Cassini spacecraft passed and delivered the aptly named Huygens probe to its surface, Titan was revealed to be shrouded in a thick, nitrogen-rich haze. Here, methane clouds rain down to form flowing methane rivers. Its surface geology also appears to be unexpectedly young, with few impact craters, suggesting it had been resurfaced in its recent past. In Chuk's scenario, when Proto-Titan cataclysmically collided with Proto-Hyperion, large portions of it were resurfaced, smoothing over old craters and giving it the lunar equivalent of a facelift. A large proportion of Proto-Hyperion merged with Titan, but some of the remaining fragments accreted to form Hyperion as we know it today. The outcome for this strange little moon in the simulations is consistent with observations, most strikingly that it seems to be only 400 to 500 million years old. Its irregular shape and low density are consistent with a body that formed from loosely bound debris. Its chaotic rotation is a result of the momentum of the collision. Not long after its creation, it was captured by Titan, and the two are now in a 4-3 resonance. As for Titan, the force of the collision pushed it into a highly elliptical orbit, a process that had started as soon as it became resonant with Proto-Hyperion and accelerated after the collision. As with our own Moon and Earth, tidal interactions are pushing Titan away from Saturn. But here's another twist. Cassini data revealed this outward journey is happening much faster than predicted, at a rate of approximately 11 centimeters a year. A large collision, as modeled by Chuck, can account for this. And the impact of the newly enlarged Titan goes even further. As its orbit changed shape and grew, it swept through the Saturnian system, wreaking gravitational havoc even on the giant Saturn itself. As we've explored, resonances between objects are hugely important in space, and they don't just occur when orbits align. They can also link the orbit of one body to the spin of another. Planets aren't perfect spheres. The influence of the Sun and their moons flatten them into oblate spheroids. This also causes them to wobble as they spin on their axis, like a child's spinning top. This wobble is called precession. Following the collision, Titan's rapidly enlarging orbit changed Saturn's precession, causing it to wobble faster and faster. This pushed Saturn's axial spin into resonance with Neptune's orbit. The only way that this lock could be maintained, as Titan continued to pull away, was for Saturn to tilt onto its side. Due to their formation process, giant planets are expected to have close to zero tilt, so Saturn's 27 degrees has been a puzzling anomaly for some time. This scenario, modeled by the SETI team, is one of the most convincing to date to explain it. For around 200 million years or so, the Saturnian system stabilized, but as Titan's inexorable pull away continued, it wasn't long before it caused more damage. About 100 million years ago, its orbit became locked into a 4-1 resonance with one of two inner moons. This relationship tilted Titan and shifted the orbits of the inner moon pair, leading to their collision. The force of the crash and the tidal influence of Saturn tore the inner moons apart, producing vast amounts of debris. Over time, some material accreted into new moons, some was lost, and the rest spread into the thin, orbiting disk we recognize as Saturn's iconic rings. That is how they came to be, and that is why they are so young. And as this story comes full circle, let's take stock. The tilted orbit of Iapetus, the unusual age and shape of Hyperion, Titan's thick atmosphere, youthful surface, and its expanding elliptical orbit, Saturn's tilt and the way it wobbles on its axis, and of course, the stunning rings. All part of the same violent story, all driven by Titan. This model is the first to bring together so many anomalous observations of Saturn into a single scenario. It's a bold idea, and what comes next is whether it can be confirmed. Thankfully, a new mission to the Saturnian system is already in the works. NASA's Dragonfly mission plans to send a nuclear-powered, car-sized rotorcraft to Titan. It will have the ability to fly and land on the moon's surface, collecting and analyzing samples from multiple locations. Kitted out with an array of onboard instruments to test Titan's surface and atmospheric chemistry, it has the potential to provide evidence of historical resurfacing. Scheduled to launch in 2028, it will reach Titan in late 2034. Chuck and his co-authors concluded their astonishing paper with a nod to this future mission. They note that even if the specific sequence of events they lay out is not confirmed, they think their work can frame new hypotheses about the evolution of Saturn's complex satellite system. To me, that underlines something central to the scientific process. None of the underlying physics in this remarkable study is new. Resonance, Precession and tidal forces are all very well understood, but what the team have done is show us how elegantly interconnected these processes can be. As for Saturn's rings, Cassini's last act was to dive repeatedly through the gap between its clouds and inner rings before finally plunging into the planet itself. These observations revealed that the rings are constantly changing. Individual particles jostle one another, and many fall into Saturn's atmosphere as a steady rain of ice, up to 40 tons every second. The constant loss of material implies that the rings may only last for a few 100 million years more. The Saturnian system has been dubbed a dynamicist paradise, and its interconnected evolution continues to play out. What might it look like in another 100 million years? As it turns out, we're quite lucky to be here at the right time to see its rings at all.
If you've ever watched an Astrum video and found yourself pausing just to take in the beauty of space, you're not alone. The colours, the motion, the scale, they remind us how vast and awe-inspiring the universe really is. Have you ever had your breath taken away when seeing these videos of our Sun, Milky Way, or perhaps Venus? Well, now, Patreon members have access to these wallpapers for your phone and laptop. Sign up with the link below. It's a simple way to bring that sense of wonder into your daily life while supporting future Astrum creations.